Hello, and thank you for joining me today. I'm excited to talk to you about enhancing your infrastructure lifecycle through codification. Get comfortable and let's get started. As part of this session, I want to talk to you about three things. First, I want to have a look at the DevOps movement and highlight some DevOps workflows. Next, we'll look at how these workflows align with infrastructure as code. And finally, we'll deploy some resources with two very commonly used infrastructure as code tools. But before we dive in too deep, allow me to quickly introduce myself. My name is Kerim Satirli. I'm a senior developer advocate at HashiCorp, where I focus on the infrastructure line of products. I'm at Satirli on Twitter, LinkedIn, and GitHub. So if you have any questions, concerns, thoughts, or you just like talking about baking cakes, feel free to reach out to me there. I also encourage you to ask questions during the session so we can get them answered. Remember, there is no such thing as a stupid question. It might be something that I've overlooked that's very simple, but still keeping you from learning. So please definitely ask. Now, let's talk about DevOps. DevOps is a portmanteau of development and operations. Specifically, dev, as in software development, the process of designing and architecting and engineering a piece of software or framework or even firmware. And of course, there should be testing and bug fixing. There'll be licensing questions, probably relicensing issues, and hopefully there's some pizza. On the other side, we have ops, short for IT operations. And we'll define that as the process of designing, architecting, deploying, and maintaining a piece of IT infrastructure. And of course, as with development, operators too must test, and they'll be racking and stacking while hopefully enjoying some pizza. Now, please note, we're using racking and stacking in a very loose definition because a lot of racking and stacking these days ends up being virtual through APIs. In recent years, DevOps got expanded by including a third, let's call it a pillar. SecDevOps prefixes the portmanteau with security, and that's just everything else. I'm kidding. A proper DevSecOps workflow does not front-load security. It makes security an integral part of it. So the process of securing your software infrastructure, but also your software in your infrastructure against attackers, no matter if they're inside or outside your company, is work that has to happen during many parts of the development process, literally every step along the way. So as with many concepts, these three definitions are not set in stone, and they will change over time. As we learn and mature as engineers, as operators, we will expand these definitions. What is important, though, is that all three of these are built around process and around workflows. So let's zoom in on that a little, on one specific part of the process. Infrastructure as code, or the codification of your infrastructure, is core to a good SecDevOps workflow for three reasons. Infrastructure as code means you're documenting your IT and application landscape. You're describing your resources in text, such as I'm doing on the right side of your screen. Now, this text is human readable, but it is verbose and it is not standardized. So let's turn this into something that a computer will understand. What you're looking at now is documentation that you, a human, can read. But this is also machine readable, which means an infrastructure as code tool, such as Terraform, can work with it too. And that means our human readable documentation just became executable documentation. And as we know, text can be very easily versioned, which means Git, SVN, Perforce, and other version control systems can come into play. And this allows us to version our code, which allows and enables collaboration. I can start on defining my infrastructure, commit my changes at the end of the day, hand it over to a team that's just starting, and have my colleagues commit their changes along the way. And because everything is versioned, all these changes become safer. Rollback, which we used to dread most of the time, at least in every team I was in, now becomes a much more tangible option because you can revert your code. And because we've defined infrastructure as code, we'll get the same experience every single time. Doesn't matter if we deploy it once, a dozen, or 100 times. You won't be able to guarantee this with manually creating infrastructure by clicking in an interface. Humans are lazy, humans make mistakes, and those mistakes usually happen when we're stressed out and when things shouldn't go wrong. So I work at HashiCorp, and we make infrastructure as code tools to help you solve a handful of workflows in the areas of provisioning, securing, connecting, and running applications. For today, I want to focus on two specific infrastructure applications, namely Terraform and Packer. Terraform is a commonly used infrastructure as code tool that abstracts remote APIs such as AWS, Microsoft, Azure, Google Cloud, and Citrix ADC away and allows you to interact with those APIs in a different, oftentimes simpler way. We have both fully open source and commercial options available. And together with our community, we've built a vast ecosystem around Terraform. From a software perspective, Terraform is split into what we call Terraform Core, which is the binary you run. So on the CLI, the Terraform binary, that's what we refer to as core. And we implement support for all these remote APIs in the form of plugins. This is a very important distinction because it allows us to iterate on features for the base application at a different release cadence than for plugins. These plugins or providers either come from HashiCorp, our partners, or the community. And to give you some ideas, right now we have 35 official providers, many of which get new releases and bug fixes weekly. Our partners maintain some 160 verified providers. And finally, our community has contributed more than 1,300 providers for services ranging from Atlassian Jira and CloudStack to Datadog and core infrastructure providers such as Domino's Pizza Service. Packer isn't all that different. Here too, we have an open source core and somewhat commercial options. For example, just last week, released a public beta of an image registry for Packer. And as with Terraform, we have broad ecosystem support for Packer with around 40 builders for different providers. Packer is also split into core and plugins. You might be wondering, why is he telling me all of this? Reason for that is that Packer and Terraform have a lot of parallels in the way you operate them. Both of them use the HashiCorp Configuration Language, which means that if you lean into learning one of these tools, adopting the other becomes very, very easy. And from there on, expanding to any of our other products isn't all that hard, because building on your existing knowledge will mean that you'll hit the ground running rather than just hit the ground. Now, with all that we've learned, let's talk about provisioning some infrastructure. I'd say enough with the theoretical stuff for now. Let me switch over to an editor and let's deploy some things. All right, so I'm in my code editor here, and I want to show you some resources that I'm deploying with Terraform and Packer together. We'll start by having a look at our terraform.tf file, where I'm defining a couple of providers that I'm using. Specifically, for today's demo, we're using the Azure provider, which is at version 2.8.1, and we're using the random provider, which is at version 3.1.0. And I'll get to why we're using the random provider in a bit, but the important point here is that we're defining the version attribute for both of these providers. If you remember earlier, we talked about DevSecOps or SecDevOps being an integral part of the whole experience, of the whole movement. So we want to start out early by version pinning and making sure Terraform knows which versions we want to be using. Similarly, we're also defining the Terraform version that we want to be using, which is 1.09, currently latest available, to ensure that our code will keep working. Next, let's have a look at our provider config. We've got one provider here that needs configuration, which is the Azure provider. And because I'm using the AZ CLI, so the Microsoft Azure CLI, I'm actually getting my authentication handled transparently. You might be using a service principal or a managed service identity in your setup. In that case, I've got a link in here that explains how to set that up. Next up, let's have a look at our variables. For Azure, we're going to need to set up at least two variables. One of them is a resource group name, which we're setting to Citrix Converge. And the other is the location where we want our resource group and also our other resources to be created. And I'm setting this to East US, which happens to be Virginia. If you remember from the slides earlier, this is pretty much the same configuration that we've been looking at. Now, inside Azure, resource group names need to be somewhat unique. So we want to make sure we use all the utilities that Terraform has to make these actually unique. And the way we're doing this is we're setting up a local value with a single key in there called resource group name. You'll note that this very much reflects the variable that we had earlier. And we're creating this local value, so this here, by combining the resource group name variable as well as a random string of 4 characters. I've identified this random string with a Terraform ID of 4, but of course, feel free to change this to whatever you need. Now let me show you how this looks like inside the Terraform code. So we have a first resource here, which is a random string resource. And you notice that the identifier here is 4. We're setting a length of 4 characters. We're only looking for lowercase characters, no special characters, nothing uppercase, and that's about it. Now, with the random string available as a local name, we can set up our next Terraform resource. And in this case, it's an Azure resource group. We're identifying this inside Terraform with Citrix. And we're using the local value that we created earlier. We're also using the variable for the resource group location. Now, this example is the exact example that we used before, just with some variables filled in. We're going to use Terraform specifically with a template file to render a key value file that Packer can understand. And what we're doing here is we're using the location and managed image resource group names, and we're filling these in with the outputs from the resource we just created on line 12. The values of this local value, so the local.terraform data value, is what we then actually input in a new resource called local file. And what this does is it takes the contents of the render template and writes them to a template file here inside the Packer directory. Now, let me show you how this looks like in my terminal. And first of all, I'll change into the Terraform directory. because that's where we want to carry out our first actions. And I will run Terraform init. And what this does is it will download all the providers that I've defined. So you'll note we're downloading the Azure provider, the local provider, and the random provider. And we've created a Terraform log.log.hcl file. And this contains all the information that we have on our providers. The reason this is important is that the log file contains the hashes of these providers. That means if the provider hash changes remotely, Terraform will warn me that the change has indeed occurred. The important part about that is that I can then make a choice and investigate, which basically protects my supply chain by ensuring that the provider version 281 that I have today matches the hash even 5-6 months down the road when I'm still using 2H1. So with Terraform initialized, the next thing we want to do is run Terraform plan. This will give us the output of what we think we're going to create. It will also tell us if there's any errors, such as badly defined variables or other things. And you can see Terraform has correctly parsed all of our files and is telling us that it does indeed want to create 3 resources. Now, because this is a new project, we're not changing any existing resource, we're not destroying anything, we're just creating 3 from scratch. If you remember when we looked at the code, the way we set everything up was the random string actually showed up first in the file. Then came the resource group, and finally came the local file. Terraform will figure out the correct order of the resources for you, so you don't have to worry about that, which makes deploying infrastructure a lot easier. I omitted to create an execution plan, and because of that, Terraform apply will show me this same output once again and ask for my confirmation. This all still looks good. So we'll just confirm that by typing yes. And in a couple of seconds, we'll be creating all of our resources. Now you can see the random string with 4 characters has been created. It's going to be YX6K. A resource group has been created, and we can see that a Packer configuration file has been created. And you'll note that the YX6K string has shown up here. And so what we're going to do next is switch away from our terminal to our editor. And for that, let's have a look at our generated file. Let's start with that. You can see that East US, the location that we previously defined in Terraform, is here. And you can also see that our resource group name with the YX6K suffix is here. Now this file was stored as a generated.auto.pkrvars for packervars.hcl file. And that means Packer will automatically load it. So this is great because this means we're actually using Terraform to inform some of the choices Packer is about to make. So let's have a look at what Packer is going to be doing. We'll start by opening the packer.pkr.hcl file. And the format here is very similar to what Terraform has. We're defining a provider. In this case, we're referring to it as a plugin. And in our case, we're using version 103 of the Azure provider. And we're also defining a required version of Packer, which starts at 1.7.6. So let's have a look at our source definition. We're defining a builder of type Azure ARM, and we're setting a handful of variables. And this listing is not exhaustive. The Azure ARM Packer builder has many, many dozens of variables that you can set and tweak to fit your specific use case. We're defining a managed image name and resource group name. Today, we'll be starting a Linux image, and we'll make sure our authorized keys from Packer are cleared. And finally, because we want to handle authentication transparently, we're using the Azure CLI auth. Now we've referred to a handful of variables here: an image offer, an image SKU, and an image version. Today, we'll be using a canonical image, but the workflow you're seeing here will work for Red Hat and everything else. So with the image configuration out of the way, we've got a location that we're defining. This is the location where Packer will start up a VM to build our image. And you'll note that while we have a description and a type, we're not including a default value like, for example, we do with the image version. And that's because this value for location and managed image resource group name are both defined inside the file we generated from Terraform. Both Packer and Terraform are smart enough to allow variable overrides, so we can hard-code the things we want to be hard-coded in our files while allowing overrides for very specific things. The first thing we'll do is initialize Packer in the current directory. And because I've run this before, Packer does not need to download the binaries for the plugin that we've specified, but otherwise you would see a progress bar here. And then with that out of the way, we're going to use the Packer build command for the current directory. Very simple, very similar to the previous command. And the only change I'm going to make is to force build, because I've built a couple of images before and I want to ensure that all of those are overwritten. Now, as soon as I hit enter, Packer starts up the binary. It grabs its authentication token from the AZ or the Azure CLI. It gives me a couple of warnings. In this case, I'm using the East US region. I don't have zone resiliency enabled in my build file, but Packer is aware of that being a possibility. So I'm getting a heads up on that. We're also seeing that we're deploying in East US, just as we configured through Terraform. Packer has validated my deployment template, and within 5 to 6 minutes, this whole process will be completed. Now you can see by now, Packer has started up a VM, and Azure has responded with some information from the VM, specifically our IP address. And we're getting a couple of other things. Packer is querying our machine's properties and showing us which OS disk is being provisioned, what the resource group names are, and if we were to switch to the Azure console, we could follow along there. You'll note that the resource group name that we created previously with the YX6K suffix is here. We've also reused the image resource group name for the image name, which is why both of these share the same name. And of course, we're in the East US location. Now, as I was talking, Packer finished the processing and capturing of our image. We'll just jump straight towards the end. So after a total of 6 minutes and 5 seconds, we finished our build, we finished our cleanup, and Packer has given us some outputs of information that we can use. We have the resource group name, we've got the image name. Just for the sake of completion, we also have the managed image ID. Now, what we want to do next is switch back to our Terraform directory and have a look at a handful of resources. And we'll start with a couple of network resources that I've defined here. We've got a virtual network, a subnet, and a network interface. We need to define those settings ourselves to meet our organizational needs. So with network out of the way, let's have a look at the compute we're setting up. And the first thing I want to highlight here is the Azure RM image data source, which you can see on lines 2 through 5. Now, if you remember earlier, we talked about Terraform being an API client. And most API clients, most REST API clients, understand a principle of CRUD, so create, read, update, delete. Sometimes it's also referred to as CRUDL or CRUDL, and the L stands for listing. Now, Terraform does support the read process very cleanly through data sources. This is useful when you're using resources that you're not managing through Terraform, or that you want to loosely couple. In our case, we want to loosely retrieve the ID for the image that we've created with Packer. And for that, we're using this data source. Now you'll note we're referring to this as Azure RM image with an identifier of Citrix. And in the next section, on line 8, we're referring to these data sources again. So what we're doing here is we're creating an Azure RM Linux virtual machine, and we're specifying a lot of the values dynamically. And the reason this is useful and important is that if this image here were to be generated in a different location, I would only have to update a single field throughout my whole code base, and all the locations would follow automatically. If you remember, in the network.tf file, we defined a resource for the network interface specifically, and so we're retrieving its ID here. And what we're doing here is exactly as before. We're using the Azure RM image data source with a Citrix identifier, and we're telling Terraform to retrieve the value of ID. Now let's switch back to our terminal once more, and we'll change into the Terraform folder again. We have a handful of new resources now, so let's run another Terraform plan. And if we scroll further down, you'll note that Terraform wants to create a couple of new resources for us, specifically the Linux virtual machine that we've defined with the SSH key, the OS disk we defined. We're seeing a network interface, a subnet, a virtual network, and all in all, we're seeing 4 new resources to be added. If we scroll back up really quickly, the source image ID here has been replaced with the exact ID that we also saw in Packer. So this means our data source was able to find this. So all of this looks good, and we'll run a Terraform apply. And as before, Terraform will briefly verify everything once again, and this looks good. And now we'll run the apply. What will happen in the background as I keep talking, Terraform will pull the Azure RM API and start creating resources for us. So in the first 8 seconds, we created a new virtual network. We're creating a network interface. Both of those are usually very quick operations. We've now jumped to the creation of the Linux virtual machine. Terraform is communicating with the Azure API. And after about 50 seconds, we can see that Terraform has successfully started this machine. And so now we're in the Azure console for this account. And let me search for Citrix Converge. And if you remember, we set up a suffix of YX6K, and we're seeing this reflected in our virtual network, our network interface, a virtual machine, and an image, as well as a disk. So let's go to the virtual machine. We can see it is running in East US, the name being populated, the operating system being Linux. If you remember, we based our image off of Ubuntu 2004, and that means for now, everything is looking great. And we're back. So I've got 2 resources for you. If you want the slides for this talk, you can find an abbreviated version on Speaker Deck. And on my GitHub profile, you can find all the code for today's showcase. I've also included a couple of other links to help you along your learning journey. I've got some guides in there, some more repositories, and plenty of inspiration for fun projects. And with that, we're already at the end of this session. But hopefully, I'm really hoping that this is just the beginning of your journey with Packer and Terraform. My name is Kerim Satirli. It was an absolute pleasure to talk to you today. Please feel free to ask any questions in chat, on Twitter, or on GitHub. Thank you.